Hi everyone, this is Hakim Yagantishwadu. Welcome back to our machine learning session. In the previous sessions, I clearly explained in-depth analysis of how to calculate k nearest neighbors for the given new data point. And if anyone missed our discussions on nearest neighbors, just go and watch our previous sessions. You will get a clarity how to calculate the nearest neighbors manually. In this session, I will show you how to apply KNN on the diabetes dataset by using scikit-learn. And in the previous sessions already we discussed a lot of topics, how to divide the train test split. If you missed all those topics, watch those sessions so that you will get a clarity. In this session, I will directly start how to apply KNN on the given data set. Open your Jupyter notebook previously where we stopped, right? Where we stopped up to train test split and some previous data pre-processing. And here, if you see, if you have to divide your data set into train test split, in this scikit-learn, we are having model selection package. In that, you will get this function train test split. So read all the required packages. And here, read your CSV file. In my system, this diabetic file is there in this path. And here you need to mention the path where you are reading your file. And then this is the basic analysis, basic pre-processing steps. Go and watch our previous sessions. And directly I will come to our implementation of KNN algorithm. First, you need to divide your data set into inputs and output features. That is input features. All these are the input features like pregnancies, glucose, blood pressure, skin thickness, up to age. These are the input features. And this is our label. First, I need to separate X and Y. X contains all the input variables, that is input features. Y contains output label. Execute this, which will divide your data into input and output variables X and Y. After that, apply our train test split, which will divide your data into train and test split. Why I need train test split? I given a clear clarity and discussed a separate session why we require train test split. Because I need to evaluate my model after design, right? That training data set will be used for to train our model, and test will be used to evaluate your model, whether it is how much accurately it is able to predict your new test points. After dividing your data into train test split, just you can see out of 768 records, 537 records are used for training and 231 records are used for testing. Since because I'm using a 70-30 ratio, right? Out of 768, 70% of that nothing but 537 records, and 30% of the test records are nothing but 231 records. Now, so in this session, as I told, majorly we are going to discuss KNN algorithm, KNN implementation by using sklearn. Sklearn nothing but scikit-learn. And see here, for this, I need to add the package which is required to implement this scikit-learn. Either what I told is you can declare all the required packages in the first cell itself instead of declaring different places. Maybe you can declare all the packages at one place. That will be the good practice of programming practices. Instead of declaring somewhere in the middle some other packages and some other packages in somewhere, you can declare all the required packages at one place. Maybe you can write a comment like KNN package. Maybe you can understand this package is suitable for which is required for your KNN implementation. So what is the package required for KNN implementation is from sklearn, NEIGHBORS means you need to remember the spellings, and case sensitive. Sometimes if you give capital S also it will not work, because in Python it is completely case sensitive. Small letters and capital letters are different. So that's why you need to apply this. sklearn.neighbors import k neighbor classifiers. These are the very important. You need to remember these small letter and capital letter neighbors classifier. If you miss anything, you will get an error. So undefined variable or not found module, something you can get. See here, K is capital, N is capital, and C is capital. From sklearn neighbors import K neighbors classifier. So why I'm executing again means this cell just now I have added one more statement, right? In order to consider this statement, you need to execute it again. So this is the package which we are going to use to implement our k nearest neighbors classifier. And now, so first is you need to create an object for your classifier. Create an object. Very simple. One thing is first you need to import the package and create an object, do training and do test. There are 4 or 5 lines of code. If I use Python packages, just import the corresponding package, pass your training data and test your model. And so that implementation is done. No need to write hundreds of lines of code if I use Python packages. Now, if you see how to create an object. This is my algorithm, right? So k neighbors classifier. So this is my algorithm. And for this, what are the main things? You need to mention the k value. So there is an attribute in k neighbors classifier, n neighbors attribute, n neighbors, n neighbors attribute. So for example, if I mention n neighbors equal to 7 means which will take 7 as the 7 neighbors. So n equal to n neighbors equal to 7 means it which will consider 7 neighbors. If I need 3 neighbors here, I need to mention 3. If I need 8 neighbors, you can mention 8 neighbors or 10 neighbors. We'll discuss separately in a separate session how K will impact your model. We'll discuss in separate sessions. So let us assume you are taking 7 neighbors. And if you remember, so Euclidean distance formula is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1. So here, uh, actually there is a normalized, means there is final formula called as in Minkowski distance. Minkowski distance. There will be variants of Minkowski like Euclidean distance, Manhattan distance, and so on. Actually, generalized formula for Minkowski is x2 minus x1 whole power n plus y2 minus y1 whole power n and so on. So if I need Euclidean distance, here I need to substitute n equal to 2. So if I need Euclidean distance, I need to substitute n equal to 2. So nothing but here there is an attribute. In order to mention whether I'm going to use with Euclidean distance or not, here I need to mention there is an attribute called as P attribute where I need to mention whether I need to use Euclidean distance or not. So if I mention P equal to 2 is nothing but which will consider as a Euclidean distance. And here metric is we are going to use a distance metric, right? So metric equal to Minkowski. This is the generalized formula. If I substitute P equal to 2 means which will take it as a Euclidean distance. So Minkowski, Minkow. Yeah, so these spellings are very important. If I miss anything, then it will gives you error. So I have created an object. Maybe just name this object as KNN. So KNN equal to K neighbors classifier of n neighbors equal to 7 means which will find 7 nearest neighbors, and by applying Euclidean distance formula. This is creating an object. There are two things you need to perform on top of your data set. One is training phase, and next is testing phase. Training and testing. Here in training, so if you remember our previous sessions in training, I will pass both inputs and outputs, but during testing, I will pass only inputs, which will get the predictions, and these predictions are compared with actual outputs to test how much accurately my model is performing. So see here during training phase, this k-neighbors classifier will provide one function called as fit function. So this will provide one function called as fit function. So let us say instead of KNN model, something I can mention instead of confusing. This is just a variable name, right? Instead of confusing you, just mention a variable name. So that variable name you can give some proper name. So KNN model equal to, this is my object, right? So here what I need to do is, on top of this object, there is one function called as fit function, which is used to train your model, where I need to pass my inputs. So what are the inputs? Xtrain, and output for these input values are ytrain. Xtrain and ytrain. Xtrain and ytrain. So this is training phase. So what it will do means, if you have some 1,000 records or 10,000 records of input records and corresponding outputs, what it will do means it will calculate the distance, it will find the nearest neighbors, and then it will choose the nearest neighbors to find the final classification. So all those mathematical calculation, choosing and finding what are the patterns in the given data set, that can be happened by using this fit method, which will take your input features as well as your input, means whatever the outputs for these inputs are considered during this training. And so what are our test values? X test is our test values, right? I need to check how much accurately my model is performing. There is one function called as dot predict function. KNN model dot predict function. So for this predict function, I need to pass my test values. So please remember here, don't pass any output values during testing. Here I need to pass only inputs. So if you pass your input, what it will do, it will gives you predictions. So those predictions I need to assign. So I can assign it to some variable. See here what this step is doing. I am passing these test values to my predict function, which will predict the values. And already I'm having test values as output. Y test is my output values for my test inputs. So what it will happen is I need to compare how many are exactly matching with these predictions and y-test values. In order to find the accuracy of my model, again, in scikit-learn we are having, so actually if I don't use scikit-learn package, accuracy score, I need to manually calculate how many exactly predicted. Instead of that, my scikit-learn package having one package to calculate accuracy. This is for accuracy calculation. So from sklearn.metrics, sklearn.metrics import accuracy score. Accuracy score. Import accuracy score. From sklearn.metrics import accuracy score. So for this accuracy score, if I pass my original predictions and so original values and predicted values, then it will calculate the accuracy. So for this accuracy score, what I need to pass? What are my actual values? What are my actual values? What are the predicted values? So what it will do means it will calculate how many accurately predicted and then it will gives you accuracy score. So maybe you can store in some variable called as score and you can print final accuracy score. Final accuracy score. Just 3-4 steps. See here, same steps we are going to perform for other algorithms also. So just 3-4 steps. Not only for KNN, so for everything you are going to follow for other algorithms like random forest or decision tree or SVM. We are going to follow these steps. First, you need to create an object and then you need to call the corresponding training method. And then you need to pass your test values to predict to see how much accurately your model is able to predict. And if I execute this, see here it is giving 69%, 0.692 means 69% it is giving accurate. But these accuracy is not enough. We need to improve this accuracy by changing a different parameter tuning or applying different algorithm that we can see in the later sessions. So how to apply KNN by using sklearn is this is the simple method. First you need to import the corresponding package for KNN, that is K neighbors classifier, and you need to remember capital letters, small letters, and then create an object for your KNN and pass your train values during fit method, which is nothing but training, and then test your model by passing your test values and find the accuracy score of your model. So after applying this, you need to apply multiple algorithms or parameter tuning to get the better accuracy for your data set. So that's all for today's session. That is about how to apply sklearn for your diabetes prediction data set.